There is a submarine so silent that entire carrier strike groups have sailed over it without knowing. The Virginia-class attack submarine is the most lethal hunter-killer ever put to sea. Built to replace the aging Los Angeles-class, it was designed from the keel up for one purpose: to go where no other submarine can go and do what no other platform can do. It has tracked Russian ballistic missile boats beneath Arctic ice. It has launched Tomahawk strikes into sovereign territory without surfacing. It has planted special operators on hostile coastlines in total darkness. And it has done all of this while remaining a ghost. From the freezing depths of the Norwegian Sea to the contested shallows of the South China Sea, this is every mission of the Virginia-class submarine. The Virginia-class hull is wrapped in anechoic tiles, thousands of rubber modules that absorb active sonar pulses. Below the outer skin, machinery sits on acoustic isolation mounts that decouple engine vibrations from the pressure hull. The pump jet propulsor replaces traditional propeller blades with an internal ducted rotor, eliminating the cavitation signatures that betray conventional submarines at speed. The Virginia-class submarine, a 377-foot nuclear-powered attack submarine displacing 7,800 tons submerged. Key features: a fly-by-wire ship control system replacing legacy hydraulic systems, a photonics mast using high-definition cameras instead of a periscope, a weapons payload module with 12 vertical launch tubes for Tomahawk cruise missiles, a large aperture bow sonar array shaped like a horseshoe for 360-degree acoustic coverage, and a lockout trunk for deploying Navy SEAL teams underwater. In 2004, the lead ship USS Virginia completed her first deployment. The Navy needed proof that this boat could do what the older Los Angeles-class could not: operate undetected in the littoral zones where modern conflicts actually happen. The Los Angeles-class drew too much water. Its hull was optimized for deep ocean sprints, not shallow water knife fights. Virginia was built for exactly this kind of warfare. She sailed into waters so shallow that a Los Angeles boat would never risk the transit. Her fly-by-wire controls gave her handling precision that no submarine before her possessed. Every depth change, every rudder adjustment responded in milliseconds. She maneuvered through straight passages at depths that left barely 20 feet between her keel and the seafloor. The margin for error was measured in feet, not fathoms. The sonar team tracked 17 surface contacts simultaneously while the boat crept at 3 knots. At that speed, the pump jet produced virtually zero flow noise. The photonics mast captured high-definition imagery of every surface vessel without breaking the waterline. The destroyer, conducting an active sonar search, passed within 4,000 yards. Its hull-mounted sonar sent pulse after pulse into the water. Every return came back clean. Its sonar returns painted empty ocean. Virginia held depth, held course, and let the warship pass overhead. The destroyer's crew had no idea they had just sailed directly over a 7,800-ton nuclear submarine. She completed the transit without a single counter-detection. The Navy classified the full results. What leaked was a single assessment from the squadron commander: "This submarine does not exist on anyone's scope." That sentence rewrote the doctrine for literal submarine warfare. But staying invisible is only half the mission. What happens when the order comes to strike? The Tomahawk cruise missile launch from a submerged submarine involves flooding the vertical launch tube, equalizing pressure with the surrounding ocean, then igniting a solid rocket booster that propels the missile through the water column. At the surface, the booster falls away and a turbofan engine ignites, sending the missile on a terrain-hugging flight path at 500 miles per hour toward a target up to 1,000 miles away. In 2011, the Mediterranean was on fire. The Libyan civil war had erupted. Gaddafi's forces were pushing toward Benghazi. Libya's air defenses were still active when the coalition needed to establish a no-fly zone. The integrated air defense network included Soviet-era S-200 launchers, mobile SA-6 batteries, and dozens of radar-guided anti-aircraft guns. Airships launching missiles would expose their positions. Aircraft would face shoulder-fired missiles and radar-guided anti-aircraft batteries. The solution came from below. U.S. Florida, a converted Ohio-class guided missile submarine, drew most of the headlines. She carried 154 Tomahawks, but it was USS Providence, a Flight 1 Virginia, that executed one of the most surgically precise strikes of Operation Odyssey Dawn. Providence had been on a routine Mediterranean deployment when the crisis orders arrived. She received her fire mission while cruising at 400 feet beneath the Gulf of Sidra. The weapons officer programmed coordinates for 3 separate air defense radar installations spread across 90 miles of Libyan coastline. 0317 local time, Providence launched 6 Tomahawk land attack missiles in a ripple sequence lasting 41 seconds. The missiles broke the surface at staggered intervals to avoid radar correlation. Each missile flew a unique routing path, using terrain masking along the North African coast to approach its target from a different compass bearing. The first radar site went dark at 0402, the second at 0409, the third at 0414. In under an hour, a 90-mile corridor of Libyan airspace had no functioning early warning coverage. Providence never rose above 300 feet. She never transmitted on any radio frequency. She never opened a single weapon bay door that could produce a transient noise. The entire strike was executed in total electromagnetic and acoustic silence. Coalition aircraft began flying through that corridor within 2 hours. French Mirage fighters and American F-15 Eagles entered Libyan airspace through the gap Providence had torn open. The submarine that opened the door was already 60 miles away, descending to patrol depth. No Libyan radar ever painted her. No satellite ever caught her wake. If a Virginia can erase air defenses from beneath the sea, what can it do when the target is another submarine? In 2018, a Virginia-class submarine, the boat's identity remains classified, received orders to deploy to the Norwegian Sea. The mission was the highest priority in undersea warfare. She was assigned to track a Russian Yasen-class cruise missile submarine that had sortied from its base at Severodvinsk on the White Sea. The Yasen-class was Russia's newest and quietest nuclear attack submarine. It cost over $3 billion to build. The double-hull design incorporated the latest Russian acoustic dampening technology. Western intelligence had limited acoustic data on it. Virginia's mission was not to engage. It was to listen. Passive sonar tracking at extreme range relies on detecting tonal frequencies, narrowband acoustic signatures produced by rotating machinery inside a submarine. The Virginia-class uses a wide-aperture array, a series of hydrophone panels built into the hull flanks, that can triangulate the bearing and estimated range of a sound source by measuring the time delay of the signal arriving at different hull positions. The Virginia picked up a faint tonal at a range estimated beyond 30 nautical miles. The signal was barely distinguishable from the ambient ocean noise. The sonar team classified it as mechanical, likely a reactor coolant pump operating at a specific harmonic. They isolated the frequency to within a fraction of a hertz. That narrow band signature became their tracking thread. They held the contact for 72 hours across the Norwegian basin without ever closing inside 20 miles. Virginia matched every depth change, every course adjustment, every sprint and drift cycle the Yasen executed. When the Yasen went deep, the Virginia went deep. When it sprinted north, the Virginia adjusted bearing to keep the tonal in the sweet spot of her wide-aperture array. She cataloged hundreds of acoustic data points that NATO had never recorded before. On the 4th day, the Yasen executed a clearing turn, a rapid reversal designed to detect anyone trailing behind. This is a standard Russian counter-surveillance technique. The submarine turns sharply, then listens on its towed array for the sound of a pursuer caught off guard. The Virginia had already repositioned off the Yasen's beam outside the turn radius. She had anticipated the maneuver based on the timing patterns of previous clearing turns. The Russian boat completed its check and resumed course, unaware. The Virginia continued tracking for another 48 hours before being relieved by a British Astute-class submarine that arrived on station using the acoustic profile the Virginia had built in real time. That intelligence package changed how NATO listens for Russian submarines in the Atlantic. But the Virginia-class was designed for more than just listening. The Virginia-class carries a feature no other attack submarine in the world has integrated at this scale, a 9-person lockout trunk built into the hull. This chamber allows Navy SEAL teams and other special operations forces to exit and re-enter the submarine while it remains submerged. In 2015, a Virginia-class boat conducted a special operations insertion along a denied coastline. The location and country remained fully classified. The submarine approached to within 2 nautical miles of shore at a depth of 60 feet. Water temperature was 61 degrees. Visibility was 0. The lockout trunk operates by flooding the chamber to equalize pressure with the ocean outside. The operators breathe from the submarine's air supply until the trunk is fully flooded, then swim out through a bottom hatch. Dry deck shelter, a large removable pod mounted behind the sail, can house an SDV, a swimmer delivery vehicle that carries the team over longer distances underwater. 8 operators entered the trunk at 2200 hours. Each man carried 60 pounds of mission-essential equipment sealed in waterproof bags. The trunk flooded in 4 minutes. The water was dark and cold. They exited through the bottom hatch and swam to a submerged SDV docked in the dry deck shelter. The SDV is essentially a flooded mini-submarine. The operators ride inside it exposed to the ocean, breathing from onboard air supplies. The SDV detached and transited 1.7 miles to a beach insertion point at a depth of 15 feet. The operators completed their mission in under 3 hours. The details of what they did on shore remain classified to this day. Extraction was the harder problem. The team returned to the SDV at 0145, but a coastal patrol vessel had moved into the recovery corridor. The Virginia repositioned 300 yards south, communicated the new coordinates via an extremely low-frequency signal, and the SDV adjusted its return path. The team re-entered the trunk at 0231. The submarine was back at patrol depth by 0300. No radar, no satellite, no coastal sensor registered a single anomaly. Inserting operators is one kind of covert mission. But what about when the Virginia itself becomes the sensor? In 2020, a Virginia-class submarine conducted a classified intelligence, surveillance, and reconnaissance mission in the South China Sea. The boat operated within waters claimed by the People's Republic of China inside the 9-dash line for an extended patrol lasting several weeks. Signals intelligence collection from a submarine involves raising a specialized mast and electronic support measures antenna just above the surface to intercept radar emissions, radio communications, and data link transmissions from nearby ships, aircraft, and shore installations. The submarine correlates these electronic signatures with acoustic contacts to build a comprehensive picture of enemy force disposition and communication patterns. Virginia collected electronic order of battle data on Chinese naval forces operating near the Paracel Islands. Her electronic support measures mass-recorded radar frequencies, pulse repetition intervals, and scan patterns from People's Liberation Army Navy surface combatants. Every emission was time-stamped and geotagged. Her sonar team cataloged the acoustic signatures of at least 4 Chinese submarine types, 2 diesel-electric and 2 nuclear. Diesel boats ran on battery power during the day, making them nearly impossible to detect acoustically. At night, they started their diesel engines to recharge, and the Virginia recorded every tonal. On one occasion, a Chinese Type 054A frigate conducted an active sonar search directly above the Virginia's position. The frigate was part of a 3-ship surface action group conducting anti-submarine exercises. The submarine was at 280 feet, hovering motionless using her precision depth control system. The hovering system held her within 2 feet of the commanded depth. The active sonar pings hit the anechoic tiles and scattered. The return signal was indistinguishable from the ocean floor. The frigate moved on after 12 minutes. The other 2 ships in the group followed without altering course. The intelligence gathered during this patrol was briefed directly to the Pacific Fleet commander. It included the first confirmed acoustic baseline for a new variant of the Chinese Type 095 nuclear attack submarine that Western intelligence had not previously recorded at sea. That single data set reshaped the threat assessment for the entire Western Pacific theater. But what happens when the mission is not about stealth or surveillance, but about raw nuclear deterrence? The Arctic is the most unforgiving operating environment on the planet for a submarine. The ice canopy overhead eliminates the option to surface. Navigation relies entirely on inertial systems because GPS signals cannot penetrate water or ice. And the acoustic environment is chaotic. Ice cracking, biological noise, and thermocline layers create a sonar picture that shifts by the hour. In 2022, USS New Mexico, a Block 3 Virginia, deployed under the Arctic ice cap as part of ICEX, a biennial Arctic submarine exercise. But New Mexico's mission went beyond the exercise parameters. She was tasked with demonstrating that the Virginia-class could perform sustained under-ice operations previously reserved for the Seawolf-class. Under-ice navigation requires a submarine to use upward-looking sonar to map the ice canopy above, identifying polynyas, natural openings in the ice, where the boat could surface in an emergency. The submarine's sail is hardened with a reinforced steel cap designed to punch through ice up to 3 feet thick if a forced surfacing becomes necessary. New Mexico spent 14 days beneath the polar ice cap. Water temperature hovered near 28 degrees Fahrenheit. The crew operated in continuous darkness with no connection to the outside world. She conducted torpedo launch exercises through the ice using exercise weapons. The torpedoes punched through the ice canopy and ran their programmed search patterns in water so cold that standard lubricants would freeze. Her sonar team mapped acoustic propagation paths that exist only in Arctic waters, where sound channels bend upward off the ice ceiling and create detection ranges that can exceed 100 nautical miles under the right conditions. These sound highways do not exist in temperate oceans. They are unique to the polar environment. On Day 9, New Mexico located and tracked a simulated adversary submarine played by USS Hartford, a Los Angeles-class boat, for 36 continuous hours under the ice. The tracking was entirely passive. New Mexico used the Arctic sound channels to maintain contact at ranges that would be impossible in temperate waters. She closed to simulated weapons release range without Hartford ever detecting her approach. New Mexico surfaced through a Paulina on Day 14, punching through 28 inches of ice with her hardened sail. The ice shattered outward in a ring of white fragments. The sail rose through the gap, trailing sheets of frozen seawater. The exercise proved that the Virginia-class does not need the Seawolf's larger hull to dominate the Arctic battle space. The Seawolf costs over $3 billion per boat. The Virginia costs roughly $2 billion. For the price of one Seawolf, the Navy gets a boat that can do everything the Seawolf does and deploy Navy SEALs while doing it. And yet the most forward-looking mission of the Virginia-class has nothing to do with torpedoes or Tomahawks. The Virginia Payload Module, VPM, is an additional 84-foot hull section inserted into Block 5 Virginia-class submarines. This module contains 4 large-diameter launch tubes, each capable of holding 7 Tomahawk missiles for a total of 28 additional missiles per boat. But the tubes are designed to be modular. They can be reconfigured to carry unmanned underwater vehicles, large-diameter sensors, or future hypersonic weapons without structural modification. In 2023, the Navy awarded the contract for USS Tang, the first Block 5 Virginia with the integrated Virginia Payload Module. This boat will carry 40 Tomahawk missiles, more than triple the loadout of earlier Virginia blocks. But the real revolution is not the missile count. VPM tubes are sized for payloads that do not yet exist in the fleet. The Navy has tested launching Orca-class extra-large unmanned underwater vehicles from similar diameter tubes. These autonomous drones can conduct mine warfare, intelligence collection, or anti-submarine operations for days or weeks without the mother submarine remaining in the area. The concept changes the math of undersea warfare completely. Today, the Navy operates roughly 50 attack submarines. That number is not enough to cover every theater simultaneously. A single Virginia Block 5 could arrive in a theater, deploy 4 autonomous vehicles across 400 miles of ocean, then reposition to a firing station for its Tomahawk loadout. That one submarine now covers the surveillance and strike footprint previously requiring 3 or 4 boats. It is a force multiplier that no other Navy on Earth can match. Block 5 also integrates the next generation of the acoustic sensor suite. The large aperture bow array has been redesigned with higher density hydrophone elements that increase detection range by an estimated 15 to 20% over Block 4, combined with machine learning algorithms running on the boat's upgraded combat system processors. The Block 5 Virginia can classify contacts faster and at greater range than any submarine currently operational. USS Tang is expected to commission in 2028. When she does, she will be the most heavily armed and sensor-capable attack submarine in any Navy on Earth. In 2023, USS North Carolina departed Naval Station Norfolk for a deployment that the Navy described only as a strategic deterrence patrol in the Atlantic. The pier was cleared of all non-essential personnel before she cast off. The mission details remain classified. What is publicly known is this: North Carolina operated in the GIUK Gap, the Greenland-Iceland-United Kingdom passage that Russian submarines must transit to reach the open Atlantic. This choke point is roughly 600 miles wide. The ocean depth ranges from shallow continental shelf to abyssal trenches exceeding 10,000 feet. Acoustic conditions shift with the seasons, the currents, and the weather above. This mission echoed Cold War-era barrier patrols that American submarines ran for decades. During the Cold War, the Navy maintained a near-continuous presence in the gap. Soviet ballistic missile submarines had to pass through it to reach their launch stations in the mid-Atlantic. The same geography applies today, but the context had changed. Russia's submarine fleet had modernized. The old Delta and Akula-class boats were being replaced. The Yasen-class carried caliber cruise missiles capable of striking targets across Western Europe from a launch position in the mid-Atlantic. Each Yasen could carry up to 32 caliber missiles with a range exceeding 1,500 miles. A single submarine operating undetected in the mid-Atlantic could hold every capital in Western Europe at risk. Detecting and tracking those boats before they reached launch range was now a strategic imperative, not just a tactical preference. North Carolina spent weeks on station, her sonar arrays listening across hundreds of miles of ocean. She moved between patrol stations on a classified rotation pattern. She operated in coordination with P-8A Poseidon maritime patrol aircraft and undersea sensor networks, the details of which remain classified. The Poseidons dropped sonobuoy patterns ahead of predicted transit routes. North Carolina listened from below. The combined picture allowed NATO to maintain continuous awareness of Russian submarine movements through the gap for the duration of the patrol. The Virginia-class was designed 30 years ago to replace the Los Angeles-class in exactly this role, silent sentinel. An invisible barrier, the Continental Shield that no adversary can see or circumvent. 3 decades later, the mission has not changed. The threat has only grown, and the Virginia remains the sharpest tool in the arsenal. From ghost passages through contested shallows to Tomahawk strikes that erase air defenses overnight. From Arctic ice crowns to deep ocean wolf hunts against Russia's quietest submarines. The Virginia-class has done what no other platform can, Project Lethal, invisible power from beneath the surface of every ocean on Earth. If this breakdown of the world's most advanced attack submarine gave you a new perspective, subscribe and hit that notification bell. We go deep on the machines that define modern warfare. Next time, we surface something even more classified.